So now let's talk about chain rule, okay? So whenever I explain about chain rule in my class, I always explain by like, take off your clothes, okay? But let's assume I have jacket, okay? Jacket is most outside function or like in my clothes, okay? Then whenever you want to like take off all your clothes, okay, don't take off everything at once, okay? It is illegal, okay? So like in chain rule, you have to take off like from the outside to in, okay? Take off your jacket first, but keep that in mind. Whenever you take off your like jacket, inside is still there, okay? And the second is what? T-shirts, take off your t-shirts, okay? And then take off your, okay, don't imagine it, okay? And this is chain rule, okay? So like basically like whenever you want to like apply chain rule, you have to think about the layer of your function, okay? So here we go. Okay, so your function, let's say function f is most outside function, and there is another function here, which is inside. Is it okay? So like, if you want to take the derivative of this function, but keep that in mind, you have to figure out the layer, okay? F is outside function and G is second function. So like you have to take up your jacket function first, okay? F first, okay? Take up means take the derivative, okay? And keep that in mind. Whenever you take up your jacket, there is still t-shirts, right? And what is second step? You take up your t-shirts now, okay? That is G prime. Is that clear? This is like basic two-layer chain rule, okay? But if like it is like a more layer, and we're gonna apply same rule, okay? Let me show you later, okay? But let's practice from here, okay? So can you find the layers now? Here we go. Like function f has two layers, okay? Outside function is power 200, right? And the inside function is 1 plus x squared, two layer, okay? We're gonna apply this way, okay? So your f prime, or in a Leibniz form, df over dx, okay? Again, you have to like getting familiar with this form as well, okay? That is equal to outside function prime, which is 200, just power, right? And 199, okay? Do you know why I pause here? And this is like first jacket function prime, okay? Then, okay, let me write your inside function with different color, okay? It is 1 plus x squared, okay? In this form, that is stand for G, okay? Then we're gonna take up your t-shirts, okay? And G prime is 1 prime equals 0, and x prime is 1, and x squared prime is 2x. That's it, okay? So this guy does have underwear, okay? So keep that in mind. You have to count how many layers first, okay? Otherwise, you're gonna try to multiply something else, okay? Oh, no. You have to stop here because there is only two layers, okay? So what about L, okay? So well, like you guys have to formulate with, like getting familiar with this form as well, okay? Like for trigger function, we write square and in there, okay? But keep that in mind. That means cosine theta square, okay? Now it is much clearer, right? And square is your outside function, and cosine theta is your inside function. Does it make sense? Okay, so your G prime in a Leibniz form, like dg over d theta. Is that okay? Then what is that? Outside function, which is square, just power, right? And 2 and power 1. Is that okay? So just pause, okay? And then let me write your inside function, which is cosine theta. And what is cosine theta prime? That is, okay, I'm sorry, not equal. Then we're gonna multiply your t-shirts function prime. Cosine theta prime is minus sine theta, okay? You have to remember this one, okay? So that's it. This is your G prime, okay? Or if you want me to simplify, it can be written by minus 2 cosine theta times sine theta. That's it. It's okay? This is chain rule, okay? But keep that in mind. Chain rule is everywhere, okay? So you are not going to have this simple problem in your exam, but like your chain rule will be combined with the product rule and quotient rule, okay? Or the worst case is what? Product rule and chain rule and quotient rules are all combined in one problem, okay? But you will encounter those kind of problem in the exam, okay?